Hello everyone, again, this is Professor Lee, and so we are going to move on to chapter 2.5 and possibly 2.6. So 2.5 is really about what? Measures of center of the data. Now, I always think the title of each chapter is very important because it tells you what this chapter is about in a nutshell, right? So what do you think we're going to talk about? We're going to talk about measures. Measures of meaning we're going to look for a number that describe the center of the data. Now, for example, you have a bunch of numbers. Let's say you have 40 different numbers, and you have to come up with a single number that best describe the entire data set. And we are going to talk about the related topics to that question, right? You are trying to figure out a single number that best describe the entire data set. Now, before we get into the actual the formulas and technique, let's talk about some of those notation. It's called sigma notation. It looks like this. It's like M on a sideway. Now, why would they call this as a sigma? Well, this is actually a Greek alphabet letter called sigma. This is actually uppercase. You know, we have uppercase and lowercase as well, right? So same in Greek, they have this alphabet called sigma. This is uppercase sigma. And what does that really mean? That really means summation, meaning keep adding up. So if you have, like, sometimes you just say sigma x, that means there is a bunch of x, then you all add up all this bunch of x. That's what this means. Now, here in this notation, this is more sophisticated. Sometimes you can just say sigma a. That means you just add up a bunch of a's. Now, this one is a little bit more complicated. They have k equal 1 on the bottom, and you have n on the top, and you have a to the k, like that. That k right here is this k right there. And this is a starting. This is where you start when k equal 1. And what about this n? This is where you end, right? You start with the k equal 1, which is when k equal 1, it's going to be a1, right? Then the next one is a2, a3, a4. You keep adding it up all the way up to what? All the way up to n, like this. Still a little bit confusing, right? Well, let me give you another example. Let's say k equal 1, say 4. That means you start with the 1, you end at 4, right? And then you have a to the k. That means what? a1, a2, a3, a4, and you stop, because this is your starting and this is your end. You end at 4. So starting from 1, going up by 1, all the way up to a to the 4. That's really technical, right? For us for now, I'll be happy if you just recognize this. Well, it's bad drawing, bad writing. This as a summation sign, and we read this as a sigma, and you call this a sigma notation, right? Sigma notation. I mean, why do we actually studying this? Because let's say you have like 40 numbers, and that number represent height. Then if you want to add every height, then you can just say this. That means adding everything, adding all the h. H, let's say, stands for height, right? Instead of saying, oh, add h1, h2, h3, h4, age 5 all the way up to age 40. You know, instead of saying that, you can just say it like that, right? Okay, so now, what was the topic for today's class? Measures of center of data, right? So we are doing what? We are looking for one number that best describe entire data. Let's say we have a population data, which means we have access to every single data point in that population. And we are looking for what's called population mean. Now, population mean, this mean is the same thing as the usual average, right? The usual average that we know. But why don't they just say population average? Why do they have to say population mean? Well, because in statistics, average could mean something else. It could refer to a couple of different things, and they all call that as average. So it's not really precise. So if you want to be precise, then you say population mean. That's the usual average. How do you find the average? Well, you add every single data. Well, let's say we took an exam and we tried to figure out the average exam score. How do you find the average exam score? Well, we add every exam score result and divide that by number of students who took that exam, right? So you add everything. See right here? Let's say this X refers to exam score, and this N refers to the total number of students, right? And that's how you find the average. Remember, we learned this as a sigma notation, meaning what? Adding all the X, right? Adding X1 all the way to Xn. And this N is what? Population, in this case, size, meaning how many data points that you have in that entire population. And this is another weird symbol right here. What is it? This mu. And this is how we pronounce mu. That actually the symbol for population mean. And we write it like that. It's like almost like a U with the long left leg, right? So this is called mu. And what is it? It refers to population mean. What's population mean? Well, in the simple language, it's actually average of that population, right? Population mean is a parameter value. If you remember our chapter 1, we talked about parameter value. Parameter is what? Any type of result that we extract from entire population. So if you get the average from population, which is called population mean, what kind of value is that? That's a parameter value. Now, what do we call that when we extract anything from sample then? Do you remember that one? From sample, we get statistic. So when we say this is a statistical value, that means that number is from sample. If we say, oh, this is a parameter value, what does that mean? That means that number came from entire population, right? Just a little recap. So for us for now, we need to remember what this symbol is about and how do we pronounce this. We pronounce this mu, and this refers to population mean, which is population average. But how do we calculate the average? You add all the data points and divide by the total population size. Okay. Now, what about sample mean? Remember, if it's a sample value, then it's what kind of value? It's a statistic value because it came from sample. So what's the symbol for sample mean? It's actually X with the bar on top. And how do we read this? We actually read this as X bar, right? X bar. That's how we read this. So how do you actually find X bar? What, what's sample mean? Well, technique is the same thing, right? You add every single data point in that sample and you divide by sample size. So this lowercase n is actually what? Sample size. Right? Sample size. So let's go back. So this is mu. This means population mean. And this is how we write. Now notice that for the population size, we use uppercase N for population size. But for lowercase n, this is what? This is a sample size. So for lowercase n, sample size, uppercase N, population size, right? Okay. And this symbol X bar is what? That's actually sample mean. What sample mean? It's actually sample average, right? Average value from the sample. And how do you find the average? You add everything, divide by the total size. Okay. So let's do this example. Let's say this startup company has 7 people working in that company, and this data refers to a travel time to get to work, right? So this lucky person right here takes only 5 minutes to get to work. This, not so lucky person takes 43 minutes to get to work, right? And since this is everyone in that company, right? This is a small company, but still this says all 7 employees. That means this is a population data, right? This is population data. How do I know this population data? It says it right here, right? To find the population mean directly, but indirectly it says all 7 employees. That also indirectly saying this is a population data point. So what do you do with this population 7 data? How do you find the mean? Well, what do you think? How do you find the average value of this 7 data point? Well, you add them like this and divide by 7. So if you do that, add everything, that should be 174 divided by 7, type in the calculator. This is what you get. Now, what kind of value is that? This is a parameter value. Why? Because it came from entire population. And what symbol should we use for population mean? Mu, right? That's a pop symbol for population mean. Okay. If this was a sample data, anything would be different? Not really, except the final answer is going to be X bar, right? This is the symbol for sample mean, and we would have used a lowercase n here, right? So I'll say this is the symbol for population mean, but this is the symbol for sample mean. This is a sample mean. This is a population mean, right? Okay. Look at this example. Find the mean. Consider the following sample. So this is a sample data. So we use this sample mean symbol, which is x bar. How do you find the average? You add them all, divide by 11. Why 11? Because there are 11 data right here, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's why this is 11 sample size. And if you type it up, you get 2.7, just like that. Okay. Okay. Let's move on to the next one. Find the mean. Consider this following sample. I mean, wait a minute, isn't that the same question? Yes, it's the same question, right? Same as this one right there. This is the exact same data point. But instead of doing it the previous technique like this, you can actually build a table like this because you have 1, 2, 3 ones. So this x1, you know, what do you think this f is? This is a frequency, right? This is frequency. X happens 3 times. What about 2? 1 and 2. 2 happens 2 times. What about 3? Just once. What about 4? 1, 2, 3, 4, 5. 4 happens 5 times. So once you set it up like that, then this is kind of a new formula to figure out this. Now, what is this? X bar. Do you remember what this is? This is sample mean. But the formula goes like this. You add everything, x times f, and divide that by summation of f. So total, if you add all this, this is 5, then one more 6, adding 5, this should be 11. So this part right here is 11. I mean, that's what we have right here. So what does this formula actually really means? It means this. Look at that. X times F. I mean, they switched the side there. What they actually did, they did F times X, not X times F. Does it matter? Well, not really, because it's multiplication, right? 2 times 3, 3 times 2, they're both 6, right? So they actually did F, which is this 3 times X, right here. 2 times 2, right here. 1 times 3, 5 times 4, right there. And then what do? What's this symbol right here? Adding up, summation sign. So if you add it up, you get the same result. I mean, if it's like 11 data point only, I don't think I'll use this table. I mean, what's the point, right? This is simple enough. But if there's a lot of data point, and if it happens to repeat a lot of it, then I'll consider building this table and trying this slightly different formula, right? Now, what was the main topic? We were looking for a central number, meaning we were looking for one number that best describes entire data set, and we just learned the mean, right, which is the average value. Another number that best describe entire data set in the best way is what's called the median. What's median? Simply the middle number when you arrange in ascending order. And median that we use M for median. I mean, we talked about this when we were dealing with you know, 5 number summary and all that. The middle number, the Q2 was the median value. And what's that q2? It's just the middle number, right? Middle number. So how do you actually find the median in the data set? Arrange the data in ascending order, small one first and big one later, right? Sometimes you call the lower and high, same deal. And figure out, determine the number of observations, determine the size, data size, and figuring out the middle value, right? Middle value. So the position of that M is actually the total data point plus 1 divided by 2, right? That's the position of the middle value, right? For example, if you have like a 1, 2, 5, 7, 10, you have 1, 2, 3, 4, 5 different data points. Where's the median? This is the median. This is third one, right? Third data point. This is the first, this is second, this third data point. What was the sample size if this is a sample? Sample size is 1, 2, 3, 4, 5, right? So if you want this third position, this is what? 5 plus 1 divided by 2, which is what? 6 over 2, which is 3, third, right there, right? Okay. Computing a median of the data set with odd number observation. What's the middle value here? Is it 18? Because it's right in the middle? No, not yet. Because what do you have to do first? You have to rearrange it from small number to the largest number. And you pick the middle value. 3 here, 3 here. That's the middle value. Just like that. I mean, the rest is pretty simple, and they use the fact that n equals 7. So 7 plus 1, 8 divided by 2, 4. So 1, 2, 3, 4th data point, which is 23, is our median. So this is our m, right? Which is what we want here. Okay. What about this one? Well, look at this. This one has how many data points? 1, 2, 3, 4, 5, 6, 7, 8 data points. So I noticed that they're not in order, so we rearrange in order like that. Then the middle value should be right in the middle between these two data points. So how do you find the middle value between these two? Well, in this case, n equal 8 plus 1, 9 divided by 2, 4.5. That means it's going to be between 4 and 5. So the way to figure out the even case m is you just simply add these two middle value and divide by 2. I shouldn't really rewrite, so here. And this is the median, right? 24.5. Okay, so that's a middle value, that's a median value. Now we talked about the mean, which is what? The average, right? You add everything and divide by the number of data point, right? The median, which is the middle value, right? So you arrange it from small to large and you pick the middle one. Another single number that best describes entire data set, it's called mode. Mode is what? Simply most frequent observation, right? Okay. Sometimes you have no mode, nothing's repeating. Example, if data set is 1, 2, 3, 4, where's the mode? Any number that repeats? No, not really. In this case, no mode. What if the next number that you have is 1? I mean, 1 happens 2 times, so in this case, mode is going to be 1. What if you have one more data point and it's 4? Then 1 and 4 happens 2 times. So in that case, you have 2 mode. But as we say in the first case, it's quite possible that you have no mode at all, right? So mode is not guaranteed. Right? Okay, so the mode in this case, let's say this is an exam result from 20 students, and it's nicely arranged from small to large. I guess 72 happens 5 times. I think it's more than all the others. I mean, 84 happened 3 times. So in this case, mode is going to be 72 because it happens the most, right, in the data set. So these are pretty simple, right? The mean and the median and the mode, not difficult at all. Okay. Now, look at this. Calculating mean of grouped frequency table. Grouped frequency table. So, I mean, we had this formula before, right? And we were trying to figure out, I mean, if I just go back, right, this table right here, right? This table right here, from the raw data, we build a table and we use this formula. I mean, this is the same formula right here. It's just that this formula, but this time you don't really have the actual data. You have the interval and the frequency. You have interval and the frequency. So let's talk about this. Let's talk about this first line. And we are to figure out best estimate of the class mean. We are looking for the mean. What does that first line tells us? It tells us this. We have one data point between what? Between these two numbers, between 50 to 56.5. We don't know exactly, exactly is it 50 or is it 56.5. We don't know exactly what number that is, but we know in between these two numbers, it's gotta be one data point there. Now, if you have to take your best guess, what would be that number? What would be that magic number? If you have to pick one number between 50 and 56.5, what would be the best number? Is it 50? Or is it, is it close to here or is it close to here? Would that be fair? Not really. The fair number to guess would be the middle number right in between these two. So how do you find the middle number right in between these two? Well, you add these two numbers and divide by 2. And that's how you find that middle number. So, in fact, they look for that middle number of all this interval and they put it right here, right? The middle number right there. So, for example, this line right here. What does this line says? Between 74.5 to 80.5. There are 2 data points there. We don't know exactly what the data point is. Is it like 50? 75, or is it like 80? Where is it? We don't really know. So that's why we are taking the middle number between these. So how do you find this middle number, 77.5? Well, 74.5 plus 80.5 divided by 2. And if you do that, that's going to be 77.5. I mean, you can verify that with your calculator later on, things like that. So that's how we build all this midpoint. Now, once you have this midpoint and the frequency, right, these two columns right here, this X refers to the midpoint. This F refers to the frequency. So this number right here is actually came from, if I just rewrite that number, if I just rewrite that number right here, X, which is first number 53.25, times F, which is 1, plus next number 59.5 times frequency 0. In that case, the whole thing just becomes 0, plus next midpoint 65.5 times the frequency 4, plus 71.5 times 4, plus, you get the idea, right? All the way up to the last one, like 95.5 times 1. So if you type this one in your calculator, this is what you're going to get. And summation of the frequency, which is total frequency, goes here. So if you divide these two numbers, that's it. That's our final answer. I mean, it says it right here, right? It's better writing right there. All this, all the way, is equal this. And divide that by 19, which is the total of the frequency, and you get this data point. And that's the mean value for this grouped data. All right? I mean, you can also do this in the calculator setup, right? So, I mean, once we figure out what to do with the calculator, we will probably try this one later on with the calculator. Basically, you go to the table, you put this in the L1, this midpoint, and in L2, you put the frequency up to here, and then you just calculate, and this calculator automatically will figure out the mean value, and it does whole other bunch of calculations. So you can do it this way too, right? So once we get the calculator, we'll probably come back to this and we'll try to do this with the calculator. But for now, we're just happy with this manual calculation here. Okay. For the last topic, let's talk about the distribution shape. There are uniform distribution, bell-shaped distribution, skewed right, and skewed left. I mean, you can read this, but let me go back. Let me go to the graph, you know, and then we'll talk about this. Now, first, bell shape. Look at the shape. If I just draw a line roughly, it looks like this nice bell. From the middle, the left side, the right side is not necessarily identical, but similar enough. That's a bell-shaped graph, and that's a bell-shaped distribution. What about this one? Just like the rectangle, the box shape, right? As x change, the frequency is fixed at 20 in this case. Uniform distribution shape, if it's a rectangle shape like this. Now, from the middle, more data point is in the left side. You know, it's kind of counterintuitive. If there's more data point on the left side, we call that skewed right. What about here? If the more data points in the right side from the middle, then we call this skewed left instead, right? The more data point in the right side, called skewed left. More data point in the left side, it's called skewed right. Okay, so that's a basic distribution shape, right? 4 different shapes. So something like this, what do you think? This is like in this way, right? So from the middle, I guess, more data point is in the right side, so we call this skewed left, just like that, right? Not a big deal. Okay, so that's the wrap for this chapter.